Hi, and welcome to Easy A Tutoring. In this video, we are going to have a look at how to calculate percentage purity of a substance from ICP results. We're going to look at a bit of theory and some examples, and feel free to use the timestamps in the description below to skip to your desired section. Now, the very first thing that we need to do is we need to go and have a look at how to prepare a sample for ICP analysis. So, a couple of steps are involved. Step one is we need to weigh off a specified amount of our prepared product or substance that we want to send in for analysis. This can also sometimes be referred to as your impure product. And then we dissolve this in a volumetric flask using molecular water. Now, using molecular water is very important for ICP analysis because the water has already been deionized, meaning that ions that commonly are found in distilled or tap water that might influence your analysis results have been removed. Now, if we have a look at our volumetric flask here on the right, we see that in the neck, we have a line running around the neck. And for example, for this 10 milliliter volumetric flask that we see, we are using as an example, this means that that is your 10 milliliter fill line. So we have to fill it up to that line to be sure that we have 10 milliliters. Now, it's very important that we use our meniscus as a guide. So our meniscus, depending on what type of fluid that we have in which type of material that we have, can have a curvature such as in A, where the curvature is below, and B, where the curvature is above. So water in glass typically has a meniscus such as in A. And it is also very important to note that when we fill up to this line, we need to bring this line up to eye level so that we do not make a parallax error and maybe influence our concentration that we think we might have. The next step is then that we need to dilute the sample for ICP analysis. So for example, if we have our initial volume is 250 milliliters and we want to dilute this 10 times, we take 10 milliliters from the 250 milliliter flask, add it to a 100 milliliter volumetric flask and fill it up with molecular water once again. Now, ICP analysis results can be given to us in 3 different types of units. So we can have milligram per liter, ppm, and ppb. Now, what does ppm mean? ppm means that we have 1 part of a substance for every 1 million parts of our total solution or mixture. So in water, this means that we have an X amount of milligram substance per liter solution, or X times 10 to the minus 3 grams substance per liter solution. And we can also go and calculate our grams. So X grams is equal to X milligrams divided by 1000. Now, if we compare the ppm to the milligrams per liter, we see that they are in essence one and the same. It's 2 different ways of saying the same thing. Next, what does ppb stand for? So ppb is that we have 1 part of substance for every 1 billion parts of total solution or mixture. So in water, this means that we have X micrograms of substance per liter solution, which can be X times 10 to the minus 6 grams of substance per liter solution, or we can take X gram is equal to X microgram divided by 1,000,000. Now we have to go and have a look at our method that we can use to calculate our percentage purity from these ICP results. First, we are going to calculate the percentage of the desired element in a compound. So for example, if we want to go and have a look at the percentage of X in the compound XNYZ, this will be N times the molar mass of X divided by the molar mass of the compound multiplied by 100. After we do this step, we need to then calculate the mass of our element in the weighed impure product from the percent that we just calculated of the element. And once again, this impure product is simply the product that we made or the substance that you sent in for analysis. So the mass of X is equal to the percent of X in XNYZ multiplied by the mass that we weighed off of this XNYZ. Step 3 is now we have to go and get our original sample and our ICP analysis results to a point where we can compare them on the same level. Otherwise, we might be comparing apples to pears, and we want to be comparing apples to apples. After we have gotten them onto the same level for comparison, we can finally go calculate our percentage purity in terms of X. So this is simply the percentage of purity in terms of X is equal to the mass of X from the ICP result divided by the mass of X in our weighed sample multiplied by 100. Now, we can do this in two different approaches. So, well, there are more than two approaches, but I find these two the easiest because we only have to go and look and convert one of our values. So there is less chance for confusion or errors. So step 1, 2, and 4 stay the same. It is with step 3 that the methods differ. So let's have a look at method 1. So method 1 is where we want to work from our sample solution to our ICP level. So this means, for example, we want to work from a gram per 250 milliliter value to a milligram per liter value. This we can do in 3 steps. So first off, we can take our sample mass per our sample volume, 2 grams per liter. We then have to take any dilution that was done into account. Now, if we are moving from a sample to an ICP level, we usually divide by the number of times that we diluted our sample. And finally, we take our grams per liter value that we now have 2 milligrams per liter. Now, method 2 is just exactly in the opposite direction. We are now moving from our ICP value to our sample solution level. So the step 1 will be similar. Step 1 is then to take our ICP output unit, which is milligrams per liter, for example, 2 grams per liter. Then we take any dilution into account. Now, because we are moving in reverse from an ICP level back to a solution, our sample solution, we will have to multiply by the number of times that we diluted our solution. And then finally, we take our gram per liter value to a gram per initial sample solution volume. Okay. So before we take a look at some examples, I want to have a look at how do we do unit conversion easily. So let's take, for example, we want to go and take 50 milligrams per liter to a value that is grams per 250 milliliters. So now for simplicity, I'm just going to color code our mass and our volume. So if we have a look at this, we can say that this 50 milligrams per liter is multiplied by 1, and we do not change the value at all. So now we go and see, we want something that is a gram above the line, but we have to also get rid of this milligrams. So we go and write that we have 1 gram is equal to 1,000 milligrams. And we're going to do something similar for the volume. So every 1,000 milliliters is 1 liter. Now, take into account the order in which we write this. So for example, we want to get rid of the milligram unit. So we need a milligram below the line. Similarly, we want to get rid of the liter unit. So we need a liter above the line that we can cancel out. Now we go and cancel out our units that we will not be using, and we simplify. So now we have 50 grams per 10,000 milliliters. Now, once again, we can say that this is multiplied by 1, and then we are not changing the value of this at all. But now we see that we have 10,000 milliliters, and we actually want 250 milliliters. So we can go to 250 milliliters simply by replacing this 1 with 250 milliliters divided by 250 milliliters. Now we once again go and just carry over what we will not be needing at this stage or will not be adjusting at this stage. And then we go and cancel out our units that we won't be using. And then we simplify the 10,000 milliliters by dividing it by 250. So now we have 50 grams divided by 4,000. And we simply just bring down the 1 over 250 milliliters that we have left because we want our final answer to have a per 250 milliliters. Now we simply go and take our 50 grams divided by 4,000 and we get a value of 0.0125 grams per 250 milliliters. And you can use this method to convert any unit to any unit that is equivalent. So now let's have a look at some examples. So we are going to look at one specific problem using the two different methods that I mentioned earlier. So let's have a look at the problem. So in this problem, you weighed 0.350 grams of copper sulfate pentahydrate, dissolved it in a 250 milliliter flask, and diluted it 10 times. Now, from our ICP analysis, we see that we have 25.60 milligrams per liter of copper. Now we need to go and determine the percentage purity of this in terms of copper. And a very important thing to note is this pentahydrate. So we have 5 water of crystallization for every 1 copper sulfate molecule. And we need to take this into account when we calculate the molecular mass. So step 1 is to calculate the percentage copper in this copper sulfate pentahydrate. And this is simply the molar mass of the copper divided by the molar mass of the entire compound, including the 5 water molecules that surrounds the copper sulfate molecules. So first off, we begin with our molar mass of copper, and the next one we take step by step. So now let's start from the left. To calculate our molecular mass of our entire compound, we start off, we see, okay, we have copper and we only have one of those. So we add the molar mass for copper. We then have sulfur and we only have one of those. So we add the molar mass for the sulfur. And then we see, okay, so we have more than one oxygen. We have 4 oxygens that comes from the copper sulfate. And then we have 5 oxygens that come from the water molecules that surrounds this compound. So in entirety, we have 9 times the molar mass of oxygen. Similarly, we look at the hydrogen now. We see that we have 10 hydrogens. So then we have 10 times the molar mass of hydrogen. Now, this simplified is 63.546 divided by 249.681. Now we get a fractional value of 0.2 0.2545, and we can go and then just convert this into a percentage by multiplying with 100, and then we end up with 25.45%. So now we're going to use this percentage value to go and calculate the mass of the copper that we have in this 0.350 grams of copper sulfate pentahydrate. So, and this is for our 250 milliliter solution. So it is simply, we multiply our weighed sample mass, which is our 0.35 grams, with the percentage of copper in this compound. Now we can go and just simply substitute the percentage, or alternatively, we can also use the fractional value that we calculated and multiply it with our weighed off sample mass. And by finishing this calculation, we see that we have 0.0891 copper in our 250 milliliter solution from our sample's point of view. Now the next step. So step 3 is now where we have to go and decide, are we working from our sample to our ICP or our ICP to our sample? So since we are looking at an example of method 1, we will be working from our sample solution to our ICP level. This means that we will be working from a grams per 250 milliliter value to a milligrams per liter value. Now, step 1, we're going to take this gram per 250 milliliters to a value that is gram per liters. So from our previous mass that we just calculated, we had 0.0891 grams per 250 milliliters. Now we have to go and take this 250 milliliters up to 1 liter. And we know that by multiplying with 4, we can obtain this. However, to keep this value constant, so that it's the same, that we keep the apple an apple, we have to multiply by 4 at the top and at the bottom. And this gives us a value of 0.3564 grams per liter. Now our next step is we need to take dilution into account. Now, since we are moving from our sample solution, which we diluted for ICP, we are going to divide by 10 because we diluted 10 times. And this then gives us a value of 0.03564 grams per liter. Finally, we have to go and take this gram per liter value that we have now, and we need to convert it to milligrams per liter. And we simply do this by multiplying our weight with 1,000, because going from grams to milligrams, we need to multiply by 1,000. So we get a value of 35.64 milligrams per liter copper. Now we have all the information that we need to calculate our percentage purity in terms of copper. So calculating our percentage purity in terms of copper, we will be taking our copper from our ICP divided by our copper from our weighed sample, and then multiply it by 100. So our copper from our ICP, we get from the question, that was 25.60 milligrams per liter. The copper from the weighed sample we get from the previous step, so that was 35.64 milligrams per liter, multiplied by 100, and we see that this substance is 71.83% pure in terms of copper. Now let's look at the same problem, but from method 2's perspective. So since step 1 and 2 are similar, we can take our percentage copper and our mass of copper from method 1. So our percentage copper was 25.45% and our mass of copper was 0.891 grams. So now we are looking at step 3, where we will be moving from the ICP level to the sample solution level, which means that we are going to move from milligrams per liter to grams per 250 milliliters. So step A is we have to get this milligram per liter to a gram per liter value. We simply then take our mass and divide it by 1000, because converting milligrams to grams, we need to divide our value by 1000. And this gives us a value of 0.02560 grams per liter. Next, we need to take dilution into account. And now we're going to do the opposite than we did in method 1, because we are moving from an ICP level, which is a diluted version of our sample solution. So we are going to multiply by 10, and this gives us a value of 0.2560 grams per liter. Finally, we have to take our gram per liter value that we just calculated and convert it to a grams per 250 milliliter value. So we have our value that we calculated, which is 0.2560 grams per liter. And how do we move from 1 liter to 250 milliliters? Well, we simply divide by 4. But to keep this as a unit, we need to divide above and below by 4. So finally, we end up with a value of 0.064 grams per 250 milliliters of copper. Finally, we can go and calculate our percentage purity from everything that we got in the previous steps. So the percentage purity in terms of copper is then again our copper from our ICP divided by our copper from our weighed sample multiplied by 100. The difference now is that the copper from our ICP, we are going to take the value that we had from step 3, and we are going to divide it by the value that we calculated in step 2 and multiply it by 100. And then we once again see that we have 71.83% purity in terms of copper. So now we are going to move on to a DIY problem. So how this works is after I have read the problem, I'm going to give a second or two so that you have an opportunity to pause the video and try the problem on your own. And then I'm going to go through the problem as well. So for our DIY problem, we are looking at a mixture that you separated of zinc and copper. And to determine the success of your separation, you analyzed the zinc hydroxide that you formed. So you dissolved 0.250 grams of this zinc hydroxide in a 250 milliliter volumetric flask, and you diluted it 10 times. And our ICP results came back as 12.33 milligrams per liter zinc. So now to go and calculate our percentage purity, the first step is to go and calculate the percentage zinc in our zinc hydroxide, which is the molar mass of zinc divided by the molar mass of our compound, which is simply 65.37 divided by, and now we're going to go step by step again. So we have 1 zinc. So we add the molar mass of zinc plus 2 times the molar mass of oxygen, because we have 2 oxygens, and 2 times the molar mass of hydrogen. Simplified, this is 65.378 divided by 99.392, and this gives us a fractional value of 0.6578, which we can convert to percent by multiplying with 100, and this gives us 65.78%. Next, we need to go and use this percentage value to go and calculate the mass of our zinc in this 0.25 grams of zinc hydroxide in our 250 milliliter solution. So this is then simply the percentage of zinc multiplied by the weighed sample. So we can use the percent value, which was 65.78%, multiplied by our weighed sample, or we can use the fractional value that we had before we calculated the percentage. And this gives us a value of 0.1645 grams of zinc in a 250 milliliter solution. Next, we are going to calculate, going to go from our sample solution to our ICP level. So we are going to go from grams per 250 milliliters to milligrams per liter. Now in step 1, we take the value that we calculated in step 2 and we take the gram per 250 milliliter value to a gram per liter value. And this is then just simply the value that we calculated multiplied by 4 at the top and at the bottom, because we need to multiply 250 milliliters by 4 to get 1 liter. And this gives us a gram per liter value of 0.6580 grams per liter. Next, we need to take dilution into account. And because we are moving from sample to ICP, we divide by 10 because we diluted 10 times. And this leads to a value of 0.0658 grams per liter. Finally, we need to get our gram per liter value to milligrams per liter. And this is just simply multiplying our gram value with 1000 to get a value of 65.80 milligrams per liter zinc. We now have all our information to go and calculate our percentage purity in terms of zinc. And this is then simply our zinc from our ICP divided by our zinc from our weighed sample multiplied by 100. This is then the 12.33 milligrams per liter zinc that we have in our question multiplied by the 65.80 milligrams per liter that we calculated in the previous step, multiplied with 100. And this gives us a percentage purity of 18.74%. Now the next step will be to give you a moment to try this example using method 2. So from method 1, we had that our percentage zinc in our zinc hydroxide is equal to 65.78%, and our mass of zinc in our zinc hydroxide that we weighed off was equal to 0.1645 grams. Next, we need to go and determine from which level we are working, and since we're doing method 2, we are working from ICP to sample solution level. This is simply milligram per liter converted to a gram per 250 milliliter value. Step A is to take milligrams per liter to grams per liter, and we simply divide by 1000 to get a gram per liter value. And this is then 0.01233 grams per liter. Next, we need to take dilution into account. Now, since we are working from ICP to sample solution level, we have to go and multiply with 10. And this gives us a value of 0.1233 grams per liter. Finally, we can take our grams per liter to a grams per 250 milliliter value. Now we know to go from 1 liter to 250 milliliter, we simply divide by 4. And what we do above, we have to do below. So we end up with 0.0308 grams per 250 milliliter. Finally, we can go and calculate our percentage purity in terms of zinc. So this is then simply, once again, our zinc from our ICP divided by our zinc from our weighed sample multiplied by 100. In this case, the zinc from our ICP is the value that we calculated from step 3, and this is then divided by our mass of zinc in our weight sample that we calculated in step 2, multiplied by 100, and this gives us 18.72% purity in terms of zinc. So we can see that this separation was not very successful. Now, the very important thing is to go and try each one of these two methods on your own and see which one works the best for you, and put that one in your back pocket. Then you always have a method to calculate percentage purity from ICP analysis values. If you found this video helpful, please like, share with your friends, and subscribe to the channel for more educational content just like this.